And these are small changes, but they're the kind of things where, like when I was first learning Chinese, one of the things that English speakers like me have a lot of trouble with is that Is that approximately correct? Yeah. So that's really unnatural in English. That's really hard for me. But when I was learning Chinese, they taught us try to learn to use this because it makes your Chinese sound much more natural if you can use it correctly. It's really weird if you speak English because we don't have that. But they said, well, learn it because it will make your Chinese sound better. Same thing here. One on says it's not a big deal, but if you learn to avoid it, it was just like, oh, so it's a lot better. Same thing with this. The particle A, the A is technically called a particle, changes to an before a vowel. And of course, the vowels in English are A, E, I, O, and U. So you would say a planet, but you'd say an asteroid. Why? Because asteroid begins with an A. The only reason we do it is if you're a native English speaker, it sounds weird to have two vowels next to each other and have them not be a diphthong. Don't worry what a diphthong is if you don't know. It's not going to work, right? It's just a asteroid. That sounds weird. You say a proton, but an electron. A bird, but an insect. A record, but an observation. A discovery, but an unexpected discovery. There are exceptions to the rule, but they're rare. And if you make them, people will understand because they're pretty. So, for example, you actually should say a unicorn or a unique opportunity. But those are really rare. There are very few exceptions in English. Usually, if you're going to use the word a, but then the following word begins with a vowel, whether it's A, E, I, or where was it? A, E, I, O, or U, change the A to N. Small difference. What difference does it make? Very little, but it seems so much more natural. It's one of those small changes that makes a big difference. If you can do that, it just sounds so much better. Now, another tiny thing, an ellipsis in English is 3 dots, flush with the bottom of the line. Now, this is one of those cases where, when I put it that way, you're probably thinking, I have no idea what he's talking about. That's okay. This sentence is full of technical terms in actually editing. So there are English speakers who would not know what that meant either. But if I give you the examples, you'll understand. Kuhn states that there is no neutral algorithm for theory choice, which, properly applied, must be each individual in the group. Now, we know what this represents. It means in the full quotation, there were words in here that the person left out. And it's clear what the person's trying to do. But again, in English, does it make a difference to the content? No, it really doesn't. We know what you mean. But it looks really unnatural in English. If you write that way, you'll be, oh, that's really, why'd they do that? So, we don't want to do that. Really easy to fix. Kuhn states that there's no neutral algorithm with theory choice, which properly applied must be each individual in the group of the same decision. Now, so notice it's 3 dots, and it's flush with the bottom of the line. That means, see, it's here at the bottom of the line. It's not in the middle of the line. And believe me, I sympathize because it's a true story. This visit to China, the first week I was here, I had to give a presentation at a conference in Chinese. And I wrote it, I was very busy, but I wrote it like a month before I got here. So I'm writing this thing, and I did get some feedback from a Chinese colleague, but he's busy too. He said, yeah, change this. Yeah, pretty good, yeah. So I give the presentation, and I got some very helpful feedback. But one person put up his hand and said, well, if you're going to come to China, you could at least format your paper correctly. There are a bunch of formatting mistakes here. There are a bunch of things that, which, and in fairness, other people at the conference were like, well, he just got here, give him, this is his first talk, So I understand, believe me. So I was like, oh no, how do I format things? So I'm having to learn things like, okay, this is an ellipsis in Chinese, or start doing run-on sentences, because that's what you do in Chinese, or format book titles differently. So I understand it's hard to adjust. But it is the kind of thing where once you learn it, it looks a lot more natural. All right, now this is not just a matter of style, this is really important. You have to, I haven't been emphasizing this, but it's the kind of thing you really need to learn to do. You need to footnote, you need to footnote several different kinds of things. And I'm going to give you some examples. And by the way, I'm going to take this part of my presentation, and I'm going to give it to Zhang Laoshi to upload to the QQ group. So don't worry if you have trouble writing this all down. I will upload this part of my PowerPoint presentation to the QQ group so you can have all this to refer to. Because I'm going to give you a lot of information now, and I know it's hard to write it all down. So don't panic. It'll be on the QQ group. So first of all, you have to footnote a direct quotation. And from here on in, for the paper you did for today, I know if you didn't do it for today, that's okay. But for the future, do these things. So for example, if you wrote Leotard, that's the next person we're going to read. Leotard defined the postmodern tradition as one of, quotation marks, incredulity toward meta-narratives. That's a direct quotation from him, incredulity toward meta-narratives. So you have to footnote it. Even though you said, Leotard said it, and you use quotation marks. Why? What if somebody thinks it's like, wow, that's interesting. I want to go look at that. Well, they have to be able to find it. Or what if somebody thinks, yeah, but you took him out of context. You're making it sound like he means something he doesn't mean. I want to see the original text. They have to be able to find it. So if you directly quote somebody, you put a footnote mark there, and notice a footnote number goes to the right of all other punctuation. And so here's a period, there's quotation marks, if there's a parenthesis, that comes next. But then here is the footnote mark. Footnote number in the body of the text goes to the right of everything else. Don't put it inside the quotation, don't put it inside the period, put it out to the right of everything else. So you have the number there, and it's going to refer, it might be at the bottom of the page, if it's an actual footnote. It's also okay if it's at the end of the essay, in which case it is technically called an endnote. Either one's okay, whichever is easier for you, a footnote or an endnote. But either way, you gotta format it, and at the very least, make sure you have it there. So, Leotard defined the postmodern condition as one of, quote, incredulity toward meta-narratives, end quote. Footnote number corresponds to this. Jean-Francois Leotard, The Postmodern Condition, published in the city of Minneapolis by University of Minnesota Press in 1984, and this quotation comes from page XXIV, which is 24. So you have to footnote a direct quotation. You also have to footnote a paraphrase of an author you cite. What's a paraphrase? A paraphrase, well, you'll see. A paraphrase is when it's not a direct quotation, but
you're reporting what somebody said. So Kuhn knows that astronomers probably saw Uranus without recognizing it as a planet at least 17 times between 1690 and 1782. I might say that in a paper, in an essay. And if I did, I would have to have a footnote so that people could see where Kuhn said that. And now, it's not a quotation, it's close, it's a very close paraphrase. But it's not a direct quotation. But where it's a paraphrase of what he says in Thomas S. Kuhn, The Structure of Scientific Revolutions, 3rd edition, published in Chicago by University of Chicago Press, 1996, on page 115. So you have to footnote when you are citing a paraphrase of something somebody said. You also have to footnote any source of new information. Now, if you quote somebody and you use quotation marks, but you don't footnote it, in English language sources, people will say that's sloppy, that's careless. You have to give the source. If you paraphrase, but you identify the source, Kuhn says blah, 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 but you don't footnote it, they'll say that's sloppy, that's careless. You have to give a footnote. If you get new information from some source and you don't footnote it, that is plagiarism. It will get you into huge amounts of trouble. Actually, I've had to turn students in for plagiarism in the United States. I don't like doing it, but it's part of my job. It's part of my job description. If they do it, I have to turn them in. And then I turn them over to a special honor committee, which has faculty on it and students. And they evaluate the evidence, and they give a judgment. Usually, if it's your first offense, they'll just give you an F for the course. That's an automatic flunk of the course. You can take it again, and you flunk the whole course, and that will be on your record. So this is serious. You gotta be, and so that's why I haven't been enforcing it, but because I know things differ from different academic cultures, but if we're gonna write in English, you have to learn this. This is important. Because if I don't teach you this, and you go to the United States, or Great Britain, or Australia, or Canada, and you do this, it will be really bad. So, let me go back. So, astronomers began to wonder why the distance between Mars and Jupiter doesn't accord with Titius-Bode's law. Then, on the night of January 1st, 1801, Giuseppe, that's an Italian name, Giuseppe Piazzi discovered a minor planet Sirius. Now, that was in one of the papers I got this time. I know you didn't know this off the top of your head. I didn't know this either. It's a really interesting fact, right? But it's not like oh, well, everybody knows, the night of January 1st, 1801, Giuseppe Piazzi discovered a minor planet Sirius. Everybody knows that. No, they don't. So you have to know. Right? Yeah, yes, I'm sure. Now, one place you might get this, and where I found it, because I checked, and I'm like, well, where would you find this out? I just went to Wikipedia. There's a format for citing Wikipedia. And this is the format. Wikipedia contributors, because there's no one author of Wikipedia. Series, dwarf planets. That's the name of the Wikipedia entry. Wikipedia, the free encyclopedia, that's the name of the website. Here's the URL for that article. And then when you cite something on the internet, you give the date it was accessed. That means I looked it up on this date. Why? If someone goes back later and doesn't find what you said was there, you can reasonably say, well, this was when I cited it. And on Wikipedia, they keep all the old versions, so you can always find the old versions. But whatever you cite off the web, you got to give the access date. That's part of the format. So, by the way, this is really actually very, very interesting for a bunch of reasons. Right? So I'm kind of glad I got this example because it's really interesting. So, why is this so interesting? So, well, we all know the basic story because you guys wrote about this. So, so Herschel discovers Uranus, and he's like the first person to figure it out after about 100 years of people observing Uranus and not knowing what it was. Why? Because everybody thought, well, we know how many planets there are. When you see something up there, you know it's not a new planet because we know how many planets there are. So all these people, because of the prevailing paradigm, failed to identify Uranus as a planet. But Herschel did, and then once he did, very quickly people started to identify asteroids. And somebody did some research and said that astronomers began to wonder why the distance between Mars and Jupiter, which it turns out is where the asteroid belt is, doesn't accord with Titius-Bode's law. Titius-Bode's law is a law about the relative distance of the planets for each other. But the really interesting thing about the story is Titius-Bode's law is false. Been discredited. It's a false law. So people discovered Ceres, the first asteroid ever discovered, on the basis of a false hypothesis. They were led to look for it by a combination of Herschel discovering a new planet, which made them think, oh, maybe there are new planets, along with a hypothesis that was totally false. So that's kind of interesting, I think, historically. But anyway, cite it. You got to cite it. And again, I'm going to upload this to the QQ group for the course, and if you're auditing and you're not on the QQ group yet, you can add the QQ group, or if you just contact me or John Lasher, we can add you, or I can just send you this directly. So don't panic about writing this all down. But when you cite a book, usually you include the author of the book, whether it's Thomas Kuhn or Leotard, the title of the book, whether it's Structure of Scientific Revolutions or the Postmodern Edition. The edition of the book, if there's more than one. Kuhn's book is up to, I think, the 4th edition. We're using the 3rd edition. But the Postmodern Edition, there's just the one edition, so you don't need to say edition because it's only the one. The city of publication, the publishing company, the year it was published, and the pages you're referring to. There's also a format for journal articles, author of article, title of article, name of journal. I'm going to just go over these quickly. Web page, author of web page, title of web page, name of the website, the URL of the website the day it was accessed. And in the case of you learn something from another person, there's actually a format for that too. So if you learn something from me, you would say Bryan W. Van Norden, personal communication, October 20th, 2014. If you don't remember the exact date, you could just say October 2014. Or if you don't remember the exact month, you could say, well, 2014. So that's some, that's something like when it was. And all these things, again, it'll be on the QQ group. Also remember last time, I gave you a list of books to look at to help with English writing. And one of them was the Chicago Manual of Style. Another one was the MLA Handbook. Those have just exhaustive lists, very complete lists of how to format any citation you ever want to format. Now, I'm also going to upload this. This is going to be your next writing assignment. I thought I was having trouble thinking of a writing assignment, but I came up with one eventually. Write at least 400 words in English on the following topic. Your essay must be double-spaced and printed, not handwritten. You must supply footnotes for any quotations or any sources of new information that you use. Turn in a hard copy, a printout of your essay at the start of our class on October 28th. Here's the question. Leotard refers to, that's the next person we're reading. refers to Ludwig Wittgenstein's philosophy when he writes, there are many different language games, a heterogeneity of elements. They only give rise to institutions in patches, local determinism. Later in the assigned reading for this week, Leotard quotes 2 sentences from Wittgenstein. Explain what conclusion Leotard is using Wittgenstein to argue for. You must quote both the earlier reference to Wittgenstein above, that is to say, there are many different language games that have different elements, they only give rise to institutions and patches of determinism, and the later passage, the one I refer to when I say Leotard, later in the assigned reading, Leotard quotes 2 sentences from Wittgenstein. And you must properly footnote both quotations. So in other words, I'm going to want to see you say something like, for the first one, Jean-Francois Leotard, comma, the postmodern condition, parenthesis, Minneapolis, colon, Minnesota. Let me help you out a little bit here. Or do you? Oh, look, there's a format of reference to the postmodern condition. So, Jean-Francois Leotard, the postmodern condition, Minneapolis, University of Minnesota Press, 1984, and then you'll have at least one footnote for the first reference to Wittgenstein. And you'll have at least one footnote for the second reference to Wittgenstein. And they can be formatted like this, it's just the page numbers will change, depending on which page you're referring to. And I say a significant portion of your grade for this essay will depend on how well you follow my directions about avoiding run-on sentences and properly formatting footnotes. And as always, at the end of every assignment, I say, you are allowed, indeed encouraged, to discuss this question with me or with other students in the class prior to writing your paper. My office hours are Monday, 1500 to 1700, or by appointment. My office is in the Judge Baylow, Arling Yao. Please footnote any discussions with other students or professors. Please footnote any discussions with other students or professors. I do not recommend consulting outside sources, books, articles, or websites on this topic, because I want you to think about it for yourself. However, if you read anything on this topic, footnote. That's always in my questions. It's always there. But now I want to make sure you actually do it. And again, it's just, I should have been enforcing this from the beginning, but I was focusing on other things and teaching you other things. So, but for your own sake, this is something you need to learn. So, and again, since I have those office hours, if you get to the Monday and you say, I don't know what to do, I don't know what it means, I don't know how to write it, come to my office hours. People who come to my office hours will tell you, I'll sit there for 2 hours and go over it as much as you want. I'll go over it again and again. And if you can't make my office hours, let me know. And I'll meet you some other time. And I'll go over it again and again and again until you feel like, oh, I get it now. I know what you want. So just ask. I'm here to help you. So I'm going to stop this for now. What I want to do is this one. Okay, that's right. All right. Okay, so now we'll get to the fun stuff. Kuhn. So I had to look at chapter 12 today, and also the postscript to the book. And some of the most important ideas in those sections are about incommensurability, which becomes a really key term in philosophy after Kuhn, and issues about whether it is possible to rationally change your views about a paradigm. So what is incommensurability? Kuhn stresses 3 aspects of incommensurability. So suppose we got 2 theories. And so here's one theory. Got another theory over here. Suppose they're incommensurable. What does that mean? One aspect of what it means is that there is disagreement over the criteria, the standards you should use for judging a theory. So one aspect of incommensurability is that the people who are working under paradigm 1 with its theory, and people who are working under paradigm 2 with its theory, they do not agree on all of the standards for evaluating a theory. What would be an example? Well, and this is one of the things that I thought was really interesting that I learned from reading Kuhn that I would not have known otherwise. So when he says it, I'm like, oh yeah, that's a good point. Now, in the classic Aristotelian worldview, so let's say the theory 1 is Aristotle's view of the planets, and theory 2, Newton's theory of how the planets move. So theory 1 is Aristotle's view of how the planets move, and theory 2 is Newton's view of how the planets move. These views are incommensurable in part because they disagree over the criteria, the standards for judging a successful theory. How so? One of the things that was central to Aristotle's view was that he provided a very intuitive and commonsensical, in a way, explanation for why the planets moved. Why do the planets move on Aristotle's view? Well, here's a kind of simple diagram. I think actually I have some of the things out of order on this because you get the basic idea. Earth is in the center, it doesn't move. Next, you have the moon. And then beyond that, you've got, Venus, and then Mars. I think Mercury should actually be in there, but whatever. Then the sun. Why do these things, the moon and Venus and Mars and the sun, why do they move on Aristotle's view? Aristotle says that there are spheres. Balls, globes show, they're spheres. And these spheres are made out of a special kind of matter. It's a kind of matter which is completely different from any matter on Earth. And Aristotle says, well, it's not surprising that the stars are made of a different kind of matter from anything on Earth because they don't look like anything on Earth. And they don't move like anything on Earth, so nothing strange about that. And then Aristotle says, each star or the moon is in a sphere of transparent material which moves. And so the planets are carried in these spheres, and that's what keeps them moving. So the moon is moved because it's built into the side of the sphere which rotates. And Venus moves because it's built into a sphere which is just around that sphere which rotates. And Mars moves because it's built into a sphere which is just around that sphere and rotates. And the sun moves because it's in the next sphere which is just outside that one and rotates. And why do they rotate? Because God moves them. Explains motion perfectly sensibly. Now, we're so used to Newton's theory, and this is what I thought was interesting for me about reading this in Kuhn, when Kuhn explains this. We're so used to Newton's theory of gravity that we don't notice how strange it is. What is Newton's explanation for why the planets move? Part of it has to do with conservation of momentum. Space is a vacuum, so no friction, blah, blah, blah. But a major part of Newton's explanation is, well, gravity keeps the planets from flying away. What's gravity? It's a force. What does that mean? Well, it's a force. The sun just kind of reaches out and grabs planets and doesn't let them go away. Well, like how? Does it push them? Well, no, it doesn't push them like, I'm pushing this. That'd be ridiculous. No, the sun reaches out over empty space and grabs things and doesn't let them go away. That doesn't make any sense at all. So in the Newtonian view, gravity is actually not explained. Gravity is measured. So in the Newtonian view, gravity is measured, but not explained. There's no explanation in Newton's view for what gravity is or how it moves things. It just does. And we're so used to, I don't know how much science background you have, but if you have some basic science background, you just get used to the idea that, well, gravity pulls things. That's what it does. But a major problem with Newton's view at the beginning was people said, I don't know what you mean. Aristotle's view makes sense. Things are pushed. So the moon moves because it's pushed. It's in a thing that's moving. Of course it moves. The moon moves for the same reason that bottle moves. It's attached to something that's moving. So it's really a very easy explanation. So Aristotle's view and Newton's view are incommensurable in part because Aristotle's view wants an explanation for why planetary motion occurs that makes intuitive mechanical sense, like pushing. It wants motion to be explained in terms of pushing. Newton's theory measures gravity but doesn't explain it. It says, well, we don't think that's a problem, but we can't explain what gravity is. So in that way, the two views are incommensurable. Another example of incommensurability would be, we'll take Aristotle again. Theory 1 be Aristotle, and theory 2 be Copernicus. And of course, Copernicus famously argued that the sun was the center of the solar system, whereas Aristotle has a view like that, where the Earth is the center of the solar system. The second kind of incommensurability, according to theory, people with different paradigms see different things. They see different things. How so? Aristotelians, when they look at the motion of, for example, the sun, or if you observe the sky at night, it turns out that all the stars appear to rotate around the North Star. If you observe the stars, they all appear to move. And Aristotelian would say, what I observe is the sun moving. I observe the stars rotating. Those are what I observe. Copernicus is going to say, well, you don't really see the sun moving. It's just apparent motion. It looks like it's moving, but it's not. You're not really seeing the sun move. And when you look up at the stars, and the stars seem to move, yeah, they seem to move, but you're not really seeing them move. You should you think about it when you try to, and again, this was Kuhn's point, right? Remember, at the beginning we read Kuhn's, the preface to The Essential Tension, and he said, the hard thing about a historian is, you gotta take something that looks like it's crazy in the past, and ask yourself, why is it not crazy? Why did a smart person say that? And so you look at Aristotle, you're like, why did this guy think the Earth was the center of the solar system? That's nuts. And you realize he had a bunch of good reasons. And there were a bunch of good reasons people didn't believe Copernicus. One of them was, it's kind of like if I said, if somebody asked you, hey, did Van Norden show up for class tonight? Did Van Norden show up for class tonight? You said, oh yeah. How do you know that? Oh, I saw him. I heard him lecture. He said, no. You just think you saw him lecture. I admit it appeared that Van Norden was lecturing, but he didn't really lecture. You'd say, you're nuts. I mean, of course I saw him lecture. He was right there, right? So likewise, the Aristotelians say, what do you mean the sun doesn't move? Look at it. What do you mean the heavens don't turn? Look at them. What do you mean the earth moves? Does it feel like you're moving? And the problem with the Copernicans is they have to re-describe all these things. They say, well, yeah, it looks like the sun's rising. It looks like the heavens are turning. It doesn't feel like we're moving. And you get used to seeing the world that way, so it starts to make sense. The third issue, of course, the first issue is people disagree over the standards for judging a good view. Second difference is they see different things because they have different paradigms. The third is they had trouble translating from one paradigm into another. They had trouble translating from one paradigm into another. And here I'm going to stop picking on Aristotle and I'm going to do Newton versus Einstein. And I'm going to do them on terms space, time, mass, and energy. Now, in Newton's physics, space is absolute. What do I mean space is absolute? I mean, in Newton's physics, there is an absolute fact about where something is located. And time is absolute in Newton's physics. What does that mean? It means time, temporal duration. I mean, not 5 o'clock or 6 o'clock. Obviously, that depends on where you are. But time in the sense of 5 seconds is 5 seconds. Whether you're on the moon or you're here, whether you're on a train or you're sitting still, 5 seconds is 5 seconds. 100 miles away or 100 kilometers away is 100 miles or 100 kilometers wherever you are. Mass is preserved and energy is also conserved. I should say conserved. Energy is conserved and mass is conserved. Now, when Einstein came along with his theory of general relativity, many people had trouble accepting it. Why? Because Einstein uses the word space, he uses the word time, he uses the word mass, and he uses the word energy, but they don't mean the same thing when Einstein uses them. They mean something. Because Einstein thinks that space and time are relative. So 5 seconds here on Earth may be 100 years if you're traveling on a spaceship. There's a famous, you might know this one, the famous twin example. Einstein's theory predicts, and apparently there's good reason to believe this is true, if you left on a spaceship, right, and you traveled very close to the speed of light, and the clock on your spaceship, you went out and you came back, and the clock on your spaceship said you had been away for a year. And it was a really good clock, and it was accurate. When you came back, everybody you know could be dead. Because a century could pass, or more, depending on how fast you're going. You say, what the heck happened? Einstein would say, time is relative. When you're traveling fast, time slows down. We don't usually notice it, because we're usually not traveling very fast relative to the speed of light, but when you get really fast, time slows down. Newton would say, that doesn't make any sense. Time is time, space is space, they're absolute. Einstein says, nope, they're relative to your perspective. He's using the same words, but in a different way, so it's actually very hard to translate what Einstein is saying back into Newton's language, because it looks like they're the same words, but they're not used in the same way. We'll look at some more problems after a quick break. 我们休息一下。Oh, you don't have to. Again, 2.5 is a good grade. Yeah, but it's one way in which you could together was to explore that. So, but 8.5 is very good. And you're
什么纸啊？我还没写什么纸啊？
就是那个要拿学的。
I mean, really.
我帮你们做一个吧。没有啊，就这一门。那你是没修是吧？你是来玩儿来助教是吧？啊？我媳妇儿，我写跑题了，我就能顾就行。交不交吧？啊？交不交？现在？我不知道，我先写上，我交给他，不知道。他这个论文交不交？交啊。
Yeah, difference is just in the U.S. Usually long.
那谁写了吗？阿涛写了吗？看到了，真没写他的，他在哪？他来了没？来了是吧？是不是好多人没有啊？没写，交作业了吗？不知道啊，我知道。哎，你们有没有？就是要他来发挥那个。
都没有学分吗？那谁要学分的，我们这儿写上啊。
这个跟说，交了啊，交了吧。
就是选课的同学啊，选课的同学，你们这儿写的那个啊。
But even in the U.S., I read some good authors.
别跑题儿了，这回又。你还没写。
你每次很早说完才。
Well, here it's again in the U.S. usually we use a double here. In Britain, they usually use 6. And so, again, as long as you're consistent,
那写反正。
as long as you're consistent. So you use double. People are like, okay, he's being sure. Okay, so we'll talk a little bit more about Kuhn on incommensurability. So, what does he mean by incommensurability? Part of what he means is two theories are incommensurable if they don't agree on enough of the criteria, enough of the standards for judging a theory to reach an agreement. So the standards are just different enough that they can have trouble reaching agreement. The second thing he means is because they have different paradigms, they'll see different things, even if they are, in some sense, looking at the same thing. So, the Copernican and the Aristotelian are both watching the sunrise, and for the Aristotelian, they're saying, I'm seeing the sun move. That's exactly what I'm seeing. The Copernican says, you're seeing apparent motion, seeming motion, not actual motion. A third one is translatability, which is especially a problem when you have a major change in which key terms get used in a new way. So, Einstein, not only does Einstein think space and time are relative, Einstein also thinks that we should really talk about space-time. So Einstein says the correct physics doesn't talk about space and time separately. The correct physics sees them as part of one way of living in the world. I'm tempted to say some more about that because it's really cool. I'm going to restrain myself. If you come to my office hours and you want to know more about Einstein's view, I'll talk about it. But it's very cool. But it's just I don't want to get distracted. And also, Einstein says mass and energy are not conserved independently. Mass energy is conserved. And the conversion between mass and energy is described by his famous formula, E equals mc squared. What does that mean? It means energy equals mass times the speed of light squared. Which means, if you played with the numbers a little bit, you'd see, if you took a little bit of mass and you converted it into energy, you would get a lot of energy. And that's what happens in an atomic bomb or a hydrogen bomb. You take a little bit of mass and it gets converted into pure energy, boom, huge amounts of power get released. And so, but Einstein said, so mass and energy are not separately conserved. They are conserved as a group. Total mass energy is conserved. So the terms mass, energy, space, time, they sound the same in Einstein's view, but they don't mean the same things. So it's very hard for the Newtonian physicists and the Einsteinian physicists to understand each other. So, now notice, Kuhn does not say it's impossible for them to understand each other. He just says it's hard because they can't just directly take space here and say it means space here, or take time here and say it means time here. It's going to be harder to do. Now, if Kuhn is right, and if theories are incommensurable in times of scientific revolution, then how is it possible that scientists come to believe a new theory? How does that happen? So Kuhn has a discussion of conversion to a new theory. Now, the use of the word conversion is very interesting, because conversion is usually a term associated with religion. So you convert to Buddhism, or you convert to Christianity. So it's usually a religious term of a change in religious faith. So it's already controversial that Kuhn decides to use this term to describe a scientist who was a Newtonian and converts to Einsteinian physics, or was an Aristotelian and converts to Copernican astronomy. But how does that happen? Well, Kuhn says when conversion occurs, generally we'll see several features. The new paradigm will usually solve some of the problems that led people to doubt the earlier paradigm. So, For example, we just talked about an example like this. Herschel's identification of Uranus was accepted very quickly. Why? It solved the problem of the motion of this object. Once Herschel noticed it was moving, that became in a way that, well, first he noticed it was moving. Okay, that's interesting. Then he noticed it was not moving like a comet. Now it's an anomaly. And then he says, I guess it's a new planet. People very quickly agreed why that solved the anomaly. It's like, oh, I guess that works. That makes sense. Interestingly, remember how I said at the very beginning that Aristotelian astronomy doesn't explain why gravity works? It just, other way around. Sorry, Aristotelian astronomy explains why the planets move by saying, well, like, this is a planet, this is the sphere it's on, the sphere moves, and the planet moves with it. And so you got an explanation. Newtonian physics, gravity is just a force. It's unexplained. Guess what? Einstein's theory of relativity explains gravity. And when it explains gravity, now that's a benefit of the theory. Think about how weird that is. So Aristotelians said, you shouldn't believe in Newton. He can't explain gravity. The Newtonians said, we don't need to explain gravity. That's not a requirement of the theory. Einstein comes along and says, an advantage of my theory is it explains gravity. And the physicists said, yeah, you're right, that's a great advantage. We finally have an explanation of gravity. So at the beginning of the process, they said, we don't need an explanation of gravity. And they said, that doesn't make any difference whether we have one. But then in going from Newton to Einstein, they said, oh, one of the great things about Einstein is he can explain gravity. There's an anomaly. How do you explain gravity? Einstein's theory explains it. Again, if you come to office hours, I'll talk about how he explains it. A second thing people look for that leads them to jump from one theory to another is quantitative precision. That is to say, is the new theory better at giving numerical answers, precise numerical answers? So, for example, one of the major things about the physics of Galileo that led people to prefer Galileo's physics to Aristotle's physics was that Galileo could give you precise numerical answers in number format. Whereas Aristotle's physics doesn't do that. It just doesn't give you. People like Galileo's do better. People might go to the new theory because, and this is often very powerful, Kuhn points out, might predict new phenomena that you actually discover occur. So, for example, when Copernicus questioned the Aristotelian view, and he said, no, the Earth isn't at the center, the sun is at the center. The Earth goes around the sun just like the other planets. One thing that implies is that the Earth is a lot like the other planets. So we should expect, if Copernicus is correct, that the other planets and the moon aren't really that different from Earth. Right? Remember Aristotle's view. Aristotle's view is the Earth is at the center. When you leave the Earth, everything is made out of a special kind of matter that moves without friction forever. It's a very special kind of matter. So on Aristotle's view, once you get past the Earth, everything changes. On Copernicus' view, the Earth is just another planet, so it should be like the other planets. About a century later, when people developed the telescope, what did they see? They saw that there were sunspots, spots on the sun. Again, Chinese astronomers noticed long before Galileo did, so what do you expect? There were mountains on the moon. Jupiter has moons of its own. Those things were shocking for people in that era. That's why it's hard to read. Now it's on the moon. So people, when they used the telescope, which is about the time of Galileo, they discovered there were spots, imperfections on the sun, there were mountains on the moon, and Jupiter has moons of its own, just like the Earth. This means that the sun and the moon and Jupiter are a lot like the Earth. The Earth has a moon, Jupiter has moons. The Earth has imperfections, the sun has imperfections. The Earth has mountains, the moon has mountains. That's exactly what you would expect if Copernicus is right and the Earth is just another planet. That was a big factor in the acceptance of the Copernican hypothesis, because Copernicus didn't, it follows, but he didn't say it. It's just a surprise. It's really wow. The last two factors that Kuhn mentions is, he says, sometimes you will go for a new theory because it has aesthetic appeal. Aesthetic appeal. Some of you are majors in aesthetics, nation. So what does this mean? It just means the theory is beautiful. Just an elegant, beautiful theory. And sometimes, Kuhn says, and this really drove people crazy when Kuhn said it first. Kuhn said sometimes people believe in a new theory because of faith. Now let me give you an example to show. Now so far, you might look at this and say, okay, I see you give us some reasons why theories might be incommensurable. But after all, these factors for conversion, they seem pretty sensible. They seem like good scientific reasons for going from one theory to another. But let's look at a specific case. And this is something that Kuhn knows about and has written about in detail in his own works. Let's look at the specific switch, which I talked about in this class before, from Aristotle's astronomy to Copernicus's astronomy. This was one of the major events in the history of Western science, one of the most important. And we have incommensurability between these two views. Right? They disagree over criteria for theory selection. For one thing, Copernicus's theory had no explanation, zero, for why it feels like the Earth is not moving. Copernicus had no reason. He said, I don't know why it doesn't feel like we're moving. And so that was, for Copernicans, that was, well, we don't know yet, we'll figure it out. Aristotelians said, no, that rules out that theory. They saw different things, I talked about that. Translatability was an issue. What planets meant for Copernicus could include the Earth. What planets meant for Aristotle could not include the Earth, by definition. But what about these criteria? Did Copernicus's theory, which is the theory that the sun's the center of the solar system, so this isn't right, the sun's the center of the solar system, the Earth goes around it, the other planets go around the sun, did it solve some old anomalies? No, actually didn't. It's common to hear people say that it did, but Kuhn has done extensive research on this, and his research has been confirmed by other historians. Copernicus's view did not solve any problems in Aristotle's view. In fact, it invented new problems, like why it feels like we're not moving. Well, yeah, but what about quantitative precision, right? What about how carefully precise answers Copernicus's theory gave? Wasn't any better. You hear people say that. People say, well, Copernicus's theory was better at predicting things. No, it was not. No historian who knows the facts will say that. Copernicus' theory was not more accurate. Did it predict new phenomena? As I said a moment ago, it did. That wasn't discovered until more than a century later. So it couldn't be a reason for originally believing in Copernicus' theory. It was a reason for believing it later, after the telescope was invented. But you couldn't originally believe in Copernicus' theory because a century later we're going to discover all these things. So that's not a fact. So why do people become Copernicans? It looks prettier, and I just feel like it's going to work out. It looks like one of the major scientific changes in Western civilization occurred largely because people just thought, yeah, this just looks right to me. I just have a feeling like it's just prettier, it's more elegant. Yeah, there's a bunch of problems with it. We don't have a clue how to solve those problems. I just think that's going to work out. It was aesthetic appeal and faith. That's amazing, if that's true. But that is what Kuhn suggests. Now, any questions about this so far? This is a lot of stuff. It's very complicated. It's controversial. All right. Well, raise your hands if you think of it. Now, in the postscript, Kuhn reviews some of the things he says in the book and clarifies some of them. There are a lot of interesting things in there. But there are two things, three things I particularly like to emphasize from the postscript of the book. One is that one of the lessons, and I hope this is obvious, I haven't stressed it, but I hope you're kind of getting a feel for it, maybe as the subtext, the undertext of what I'm saying. When people in the United States try to understand China, or when people in China try to understand the United States, that's not a matter of scientific theory selection. But you might have problems of incommensurability. You might have problems where there's disagreement over the standards to use to solve a disagreement. Where it's like, well, we both agree about blah, 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 but then one side says, well, yeah, but of course you agree about this and this, right? And the other side says, no, what about this and this? That's what's really important. I watched a news show once, true story. Why do I say true story? Like you're going to doubt me. I watched a news story once, true story. Like you're thinking, I don't believe you watched a news story. No. Yeah, of course I watched a news story. But the interesting part is, I watched a news story once. It was about prisons in Japan. And at least at that time, in Japanese prisons, Japanese prisoners were required to sit facing the wall and not move. And the U.S. reporter asked the Japanese warden, the person in charge of the prison, don't you think that's cruel? What about the feelings of the prisoner? And the Japanese warden said, what about the feelings of the guard? That's incommensurability. For the U.S. viewer, and I'll guarantee not everybody, but 99% of the U.S. viewers would say, oh, that's terrible. They make them sit in a chair and stare at the wall for almost the whole day. That's horrible. But obviously, the Japanese warden said, no, what's wrong with that? This is a person who's in prison. Why should they get to walk around and, talk and stuff like that? Make them sit there. There's something wrong. That's an example of disagreement over criteria. And I remember watching that, and the reason I mention it is I remember thinking, how would I argue against this person? If I was talking to this warden, what would I say to try to convince the warden that he was wrong? And it's not clear we agree about enough standards to resolve the disagreement. See different things, this happens all the time. People can see really different things. I'm not going to even mention an example dealing with the U.S. and China. A bunch of them come to mind, but it's hard to, sometimes it's hard to get a distance on something you're very close to. But let me pick an example. Robert McNamara was the Secretary of Defense when the U.S. got involved in the Vietnam War. After the war, he met one of the leading Vietnamese generals. They almost got into a fist fight. Why? McNamara, the U.S. Secretary of Defense, said, you know, if you guys had just agreed to renounce communism, we wouldn't have fought a war, and you would have saved hundreds of thousands of lives. And the Vietnamese general said, you came here to enslave us, and we had to fight you. Communism just happened to be the ideology we were using. McNamara says, that is insane. Why would you think we came there to enslave you? And I'm really, by American standards, fairly liberal, left-wing, by American standards. Probably not by Chinese standards, but by American standards, I'm pretty left-wing. I'm like, yeah, no, I don't think we were coming to Vietnam to enslave anybody. That's honestly not my opinion. I mean, I gotta say, I don't think so. And so on McNamara, I agree with that. But the Vietnamese general said, no, you're just like the French. And he said, I'm not agreeing with him. But he said, and like the Chinese before that, not agreeing, saying that's what he said. You're like the Chinese, you're like the French, all you guys want to come in and enslave us. I'm not standing for it. Communism's not important to us. Yeah, I said I was a communist, or I said I was anything. I just want to fight you guys. I want my country to be free of you imperialists. McNamara's like, that's a bunch of crap. We were just afraid that communism would spread to other countries. We just wanted to stop communism. If you renounced communism, we wouldn't have fought the war. No, that's not true. You came to enslave us. And they almost ended up on a fist fight. That's seeing things different. From the U.S. side, I'm not saying it's right. I mean, I was like 8 years old when the Vietnam War ended. But I would have opposed it. I would have thought the U.S. involvement was stupid. But, if you ask me as a U.S. citizen, do you think the U.S. involvement in Vietnam was about enslaving the Vietnamese? Honestly, no. Obviously, that's the way it looked to the Vietnamese, and that's why we're like, we'll fight you. Translatability. Does Runchuan mean human rights in Chinese? It's the word you use to translate it. Does it say anything in a Chinese context? Sometimes I teach translation because my putonghua is, but my Wenyan, that's really what I do is I translate Wenyan. I translate the Hangzi into English. I translate things like that. So that's really my thing. But so sometimes I teach translation, and one of the things I teach my students is don't just take a word and say, this word goes with that thing. You translate sentences, not words. And so a sentence that has Runchuan in it may not mean that has human rights in it in English. So that's part of why I think this course is interesting and exciting. It's not like, because I know you might be thinking, boy, this guy is really interested in the history of science. I am. I think the history of science is fascinating. But that's not the point. The point is to figure out how do we know and understand the world, including knowing and understanding each other. Russell says, just look and think rationally, and you'll get the answer. Kuhn says that won't be enough. Why? Because theories are incommensurable. So there's a deeper point here. There's a bigger point. So in the postscript, Kuhn says he makes a bunch of interesting points, but I want to stress three of them in particular that Kuhn makes in the postscript. A postscript to a book, of course, is a part of a book you write after you finish the rest of the book, usually after a period of several years. often it's responding to critics, which is exactly what Kuhn's postscript does. The three main points in the postscript I want to stress, which are things that Kuhn says, are persuasion, not proof. Theories get better at solving certain kinds of puzzles. And you need scientific theories. Scientific theories do not converge on an ontology. Ontology is just a fancy word for, it can be used in different ways, but it's often used to refer to your view of what kinds of things exist. So if you say, what's in your ontology? It means, well, what kind of things do you believe exist? So one kind of ontology would be, I just believe in material objects, nothing else. Another ontology would believe, well, I believe in material objects and souls. Or I believe in material objects, souls, and Platonic forms. Those are all ontologies. So three of the points Kuhn wants to make is science is about persuasion, not proof. What does he mean when he says science is about persuasion, not proof? So, suppose you and I are trying to do a math problem. We're trying to add 291 and 111. I get 302, and you get 402. And I said, no, it's 302. And you say, all right, well, let's just work it out. And you say, okay, Brian, 101 is 2, right? I say, yeah. And 91 is 10. I say, yeah, right, exactly, it's 10. You say, but then you carry the 1, right, Brian? Oh, yeah, you carry the 1. And 2 and 1 and 1 is 4. Okay, you're right. Now, in this case, there's an, I always forget how to spell this. It's supposed to be a Y. Nope, it's an I. Over there. An algorithm. This is one of those words that's hard to use. Algorithm. Yeah, that's actually right. Algorithm. An algorithm is like a procedure you can follow that will give you the answer. So you all learned in grade school the algorithm for adding sums of numbers. Right? You learned it a long time ago. And if you and I disagree about how to add numbers, what the total is, we just follow the algorithm and it solves, the answer comes out. I'm not going to sit here and argue with you about carrying the 1, because we both know what the algorithm is. What Kuhn's saying is there is no algorithm for theory choice. If there were an algorithm for theory choice, choice in science would be like mathematical proof. You could just prove which theory was better. So Kuhn says you can't prove which theory is better, like you can prove that 291 and 111 is 402. But, Kuhn says, that doesn't mean you can't rationally persuade somebody. So Kuhn wants to say that in science you can have rational reason to accept a theory, but not because it's proven, like you prove things in math, but because there can be a rationally persuasive argument. So you can have a good reason to believe Galileo instead of Newton, even though it's not a matter of mathematical proof. You can have a good reason to believe Einstein instead of Newton, but it's not going to be mathematical proof. Why can't it be proof? Well, for these reasons. because different theories are going to disagree on the criteria, they're going to see different things, it's going to be hard to translate. But Kuhn says that doesn't make it impossible for people to see that one theory is superior. So, I mean, one way to think about it is, we keep coming back to this example, Aristotelians, when they talk about physics, they don't measure. Aristotelians measure things, because they measure, like, the pass of the planets and when something's going to happen and things like that, the length of the year. But in everyday motion, Aristotelians don't measure things. So quantitative measurement is not a criteria for Aristotelians to judge a physical theory. It is for Galileans, so they disagree over the criteria. But once you see what a good job Galileo does measuring things, it is pretty impressive. It's pretty darn impressive when you see what he does. So Kuhn says you can have a good reason for believing something even though you can't prove it. Secondly, Kuhn says theories do get better in a certain way. They progress in a certain way. And they progress at solving certain kinds of puzzles. And I had you write about what his criteria were and about his tree analogy. And he says things like, a lot of it is just repeating things he said here, but he also talks about some new things. He says, well, there's simplicity, scope, and compatibility with other views, accuracy of prediction, quantitative accuracy, the balance between esoteric and everyday subject matter. That's a really weird sentence. It's okay if you're unsure what to do with that. What he means is something like an esoteric part of a theory is a part of a theory that only a specialist or an expert knows about or understands. So, for example, we looked at Leyden jars earlier in the course. Right? Everybody knows about lightning, but not everybody knew that you could store a charge in a Leyden jar. So the fact that you can store an electric charge in a Leyden jar, that was esoteric knowledge, something that's specialist knowledge. So it gives these criteria, but, and some of you noted this, as we saw in the case of Copernicus versus Aristotle, sometimes these don't give you a clear choice between theories. So in the postscript, Kuhn seems very confident that later theories will be better than earlier theories by basically these criteria. But if you read the body of the book, he seems to say, well, you really can't judge theories in terms of just getting better at these things, because there's no numerical way to prove that some theories are better at these than others. So it's a funny thing for him to say, but he does say that there are criteria by which later theories are better than earlier ones. But he says they're kind of puzzle-solving abilities. They're abilities like, well, it's better at solving this kind of puzzle about quantitative measurement, or it's better at this kind of puzzle about how broad it is. So that part, this is a little dubious, a little questionable, because it seems to contradict what he says in most of the book. What's really especially interesting, though, I think, which he says in the postscript is, he says, scientific theories do not seem to be converging on one ontology. Now, what does that mean? That means Kuhn is saying that scientific theories are getting better at things like solving certain puzzles, but they're not getting better. They're not getting closer to one view of what exists in the world. They're not closing in on one ontology. In other words, if you want science to solve puzzles for you, number one, science is great at it. If you want science to tell you what reality is really like, Kuhn, the former physicist turned historian, says, good luck. Because science is not headed towards any particular view of what reality is like. Now, why might he think that? He actually has very good reasons for thinking that. I came up with an example to illustrate that. Let's look at the notion of an atom. It's a basic scientific concept. I mean, surely science is converging on the fact that, atoms exist, right? That's a basic science fact. We've been converging on that. We're getting closer to understanding what atoms are. We're getting better at atoms, right? What's the original meaning of atom? Atom comes from the ancient Greek, atomos, which means uncuttable or indivisible. One or two, I think. So this is Buddha ancient Greek. So atom comes from the ancient Greek atomos, meaning uncuttable or indivisible. You can't divide it. And the original atomists were the ancient Greek thinkers, Leucippus and Democritus. Their works, their writings, are mostly lost to us. But there's a book by Lucretius, which dates from about the 1st century, I want to say BCE. Double check my notes, make sure I'm correct. Yes, I am. Lucretius wrote a book from in the 1st century. Cent, this is an abbreviation for century. BCE means before the Common Era. So BC. Lucretius wrote a book in the 1st century BC about atomism. What did Lucretius and Democritus, what did they think atoms were? They said, well, atoms are the smallest pieces of matter. They come in different shapes. And their shapes determine the qualities of the objects they're made out of. And you might be saying, wow, that's just what atoms are. That's awesome. Right? So we already have this theory. No, it's more complicated than that. Atomism as a philosophical position, some people like it, some people don't like it. It doesn't really become a well-accepted scientific theory until Dalton in the early 1800s. And Dalton is a chemist, and he's trying to explain certain chemical properties. And Dalton says that an atom is so Lucretius says atoms are indivisible, they can't be divided, they have different shapes. Dalton says that they are, he also thinks they're indivisible, and he thinks they're distinguished by their mass and their complexity. The next major breakthrough, I believe, is by Rutherford. Thompson in 1837 said, well, the atoms have a kind of structure, they've got electrons which are built into them. Then I'm going somewhere with this, so bear with me. I'm going to see if I can give you an awful lot of scientific history, but I'm going somewhere with this that will pay off. Trust me for a second. Then Niels Bohr came along, 1913, and he said, well, yeah, there are electrons, but the electrons aren't in the atom, like Thomson said. They orbit around the atom like planets orbit around the sun. So it's a little different from the way he thought about it. Then Schrödinger, in Erwin Schrödinger, Schrödinger's cat thing, if you've heard of Schrödinger's cat. I believe this was 26, double check my dates, yep. Schrödinger came along and said, well, yeah, there are electrons, but they don't orbit the way planets orbit around the sun. They're in like probability zones. They're like these zones of probability for finding atoms and finding electrons, and that's where they are around the nucleus. And then, I looked this up, I didn't know, it was a guy named Otto Hahn in 1938. I actually thought it was somebody more famous than Otto Hahn did this. But in 1938, Otto Hahn discovered that nuclear fission, the dividing of atoms, was possible. All right, now why am I giving you all this darn history of the atom? Well, I'm giving it to you just because you need a concrete example, a specific example to see what Kuhn's talking about. Right? So, atom is a basic scientific concept. Are we converging, getting closer to one understanding of atom? Well, we used to think it was this indivisible, couldn't divide it, smallest particle, and they're basically distinguished because they have different shapes. Lucretius says some of them have hooks, so some things like to stick together because they have hooks. Other things are more like balls, so they're very slippery, they fall like water. He said like shaped like balls, and they kind of fall apart. It's real quick. Dalton actually gives a theory to explain chemical reactions, and he says, yeah, no, that's right. There are these indivisible particles of matter. They're distinguished by their mass and their complexity. Mass is not the same as shape, and complexity is not the same as shape. Mass is a technical term in later physics that Lucretius and Democritus don't have. Thomson comes along and says, yeah, but the atoms have electrons that are built into them, like raisins or something in a cake. Bohr comes along and says, well, no, the electrons orbit around the nucleus like planets. Schrodinger says, no, they're kind of in like probability fields around the nucleus. And Hahn says, oh, you can divide it. Is this the same notion as that? Were we zeroing in on this? Were we getting closer to this? By the end, atoms aren't atoms anymore. The whole notion, atomos, is you can't divide them. Now they're divisible. Oh, and by the way, they've got electrons. And oh, by the way, the electrons orbit around the nucleus. Oh, no, they don't. There's a probability cloud of where the electrons are around the nucleus. We're not, and Kuhn would say, you look at stuff like this, we're not getting closer to anything, we're just changing the meaning of the term atom at every stage. So science can't tell you what the truth is, it can only tell you what the current theory of the truth is. Interesting idea. Okay, 我们休息一下吧。
要不就不选，下学期再选。
然后再多看我们看起来
是物质，还有不是物理，那个就是概率。
很强概率的说是靠最强的来概率，
说电子效应在哪儿？就是它是可以分裂下部的夸克，是可以把原子在夸克更小，对，然后还有就是你只能想象假设什么样，你不知道它真的是长什么样。假说它有一个这样的东西，然后它存不存在你也不知道，只是用一个实验来证明它。
你能证明它的存在？
对，但是不知道它假说也看不到。
你要去描述它的概率。
对，
它就是那个微观世界，它和客观世界是完全不同的。
差不多。
它就是你不能说亲眼看到的。
相当于那个不可知论，你知道它存在，但你不知道它真正是什么样，看不到。这不准定
变化太大了。
这根本没有你看不到，太小了，像我们技术还能说。
看到的但是我们证明它的变化。
它有一个叫测不准定律嘛，测不准就是你测的搞现在测不准是人，现在测是这样的，等会儿是这样的，它还会跟这个词儿X乘以多少条
跟这个长期的。
微观到底是什么意思？这个微观世界是概率，它不是概率，它讨论是什么时间在这儿？
这本书有讲吗？没有，这本书上有讲，就那个道很难讲，道顿是吧？道尔是吧？都不想，这老师讲这书，在讲那个歌话，那是跟直属套路的有点儿。科学这个东西啊，就像四维思维，这个就是他自己是大学的呀。这是什么呢？你这会儿他们这是我们这个修课科学，你来旁听了是吧？啊。我觉得你讲这个，这都显示谁？
说现在这个对原子夸克的这个越来越接近这个科学，越来越根据这些可能不同的人看法不一样。像你这样。
不同的人的世界观，
以前是我们拿那些没见过，大家可能都一样。现在呢，
越看到
结果发现在还不一样。
谁看到？
那如果是传染或者是一个东西，
就是说有个人，假设你跟一个修行好的和尚在一起，身上的电子都发生变化了，是不是这样的？如果你跟一个恶人在一起，那个人身上的气场就这样的，你的细胞也会变化。你心里就哪个看你家人跟你正常，你就觉得想眼睛。是不是也有这种感觉？你是不是觉得会这样？你身上的细胞都是电子别跟上电子运动都发生了，
然后它表现在你的心里呢，
也会有同样的。你说的这个是相反的。它有客观的应用范围，主要有主观的应用态度。你说的这个，它不是大部分的时候，它是可以影响。有的人天天说爱你，还有一个人心疼你就不同意了。大米假设他也是好像那个人他有没有思考，他怎么影响呢？
All right, so now what I'm going to do is I'm going to give you an overview of some of the main points you should
that are at least suggested by Kuhn's The Structure of Scientific Revolutions. You don't have to agree with them, but these are things that Kuhn is trying to convince us of and that are worth thinking about, at least a little bit. So Kuhn wants to convince us we do not have direct acquaintance with pure sense data. And I'm going to give you two quotations to illustrate this. The first quotation is from Russell. And Russell thinks we do have direct acquaintance with pure sense data. Russell says, we shall say that we have acquaintance with anything of which we are directly aware without the intermediary of any process of inference or any knowledge of truths. And among the things that Russell says we are directly aware of are sense data. And so Russell says we're directly aware of sense data without any process of inference or without any knowledge of truths. You're just directly aware of sense data. In contrast, Kuhn says, what occurs during the scientific revolution is not fully reducible to a reinterpretation of individual and stable data. So what is he arguing for? He's saying that, at least in a period of scientific revolution, it's not a case that we have data, you mean sense data, that is individual and stable. Rather, the data is all subject to interpretation, so we're not just reinterpreting data which is fixed because we're acquainted with it. It's not like Russell is saying, according to Kuhn. Why should we think this? One person sees a duck, another sees a rabbit. Early scientists see a jar for collecting electrical fluid, which is what a Leyden jar is. We see a condenser. Priestley sees dephlogisticated air. Lavoisier sees oxygen. Now it's tempting, in the light of this, to say, well, I see what you're saying, but beneath the level of the Leyden jar or the condenser, the dephlogisticated air or the oxygen, there's got to be some direct, pure sense data, right? But the problem is that the best efforts of philosophers to build genuine scientific theories out of pure observations have always failed. Because if you think, what would a really pure observation look like? It would look like red here now, or blue there then. And philosophers have tried to develop scientific theories or just ways to express scientific theories by using pure sense data reports, like red here now, blue there then. Always fails. Why? Well, as you can see, this is not much to work with to get to a description of what Lavoisier thinks he's doing, or what Einstein thinks he's doing, or what we think we're doing when we use a condenser. I think another really important point that Kuhn is making, and Kuhn is making this point, but I personally think it's one of the most important and interesting points that Kuhn makes, is that rationality is about persuasion, not fact. And again, I'll give you two quotations, one from Russell, illustrating the opposite view, and then a quotation from Kuhn, representing Kuhn's view. Russell says, what we firmly believe, if it is true, is called knowledge, provided it is either intuitive or inferred from intuitive knowledge from which it follows logically. And remember, for Russell, intuitive means self-evident. Like direct acquaintance with sense data, that's intuitive. You just see that it's red, you know it. Or you can deduce it, infer it logically from something intuitive. In other words, it's a logical process of inference. What does Kuhn say? Debates over theory choice cannot be cast in a form that fully resembles logical or mathematical proof. In other words, picking between theories, Kuhn argues, is not a matter of doing something like adding two numbers. And if you disagree, you just check what the rules are for adding two numbers, and you find out who's right. Kuhn thinks you can still have a good reason for believing one theory over another, but it won't be a matter of proof, as Russell had hoped it was. Why persuasion, not proof? People with different paradigms observe different things, even when looking in the same place. It makes it hard to prove anything. People with different paradigms have different standards for what counts as a good or bad theory. And people with different paradigms often cannot directly translate what they are saying into the language of a different paradigm. For all these reasons, it's going to be the model of theory choice as proof, like you have in logic and mathematics, is not going to seem adequate. Most challengingly, one of the most challenging aspects of what Kuhn said, and Kuhn doesn't want to say this, but people have read Kuhn and said the lesson to learn from Kuhn, some people say, is truth may be relative, not absolute. Let's and again, two contrasting quotations. Russell, who will have nothing to do with relativism, says, thus, coherence as the definition of truth fails, because there is no proof that there can be only one coherent system. So in the chapter where he talks about truth and falsehood, Russell discusses the possibility, which some philosophers before him had given, that a true belief is just a belief that's consistent with, coherent with other beliefs. Russell says, well, that can't be right, because you could have more than one coherent system, and that would mean there'd be more than one truth. So Russell takes it, that just shows that this test has to be wrong. Why? Because Russell thinks, obviously, there's one set of absolute truths. Kuhn sometimes says things like this: the historian of science may be tempted to exclaim that when paradigms change, the world itself changes with it. The historian of science may be tempted to exclaim that when paradigms change, the world itself changes with it. Why might you be led to believe in relativism? We talked a little bit about relativism last time. Some claims are obviously relative. If I say, is the door on the left or the right? Well, it's to my left, it's to your right. If we got into an argument over whether the door is on the left or the right, that'd be a pretty stupid argument. It just depends on your perspective. But the interesting question is, are truths in general all relative? And some of the things Kuhn says might lead you to believe that all truth is relative. All truth depends on your perspective. All truth depends on your paradigm. Why might you think that? Well, it seems that, based on what we've read in Kuhn, there's no way to judge the truth of a theory independently of a paradigm. It looks like you need a paradigm even to observe the world, or to have standards, or to have a language in which to talk about truth. Therefore, truth seems to depend upon one's paradigm. There'll be one truth for Priestley, a different truth for Lavoisier, one truth for people who think a Leyden jar is a jar for collecting electrical fluid, another truth for people who describe it as a condenser. And another reason for believing in relativism is that historically, as the example of the atom shows, it seems that science is not getting closer and closer to one theory with one ontology. We use the word atom, or its ancestors in Greek and Latin, have been used in the West since the time of Leucippus and Democritus, who I think are 5th century BCE, and then Lucretius, whose book actually survives, in the 1st century BCE. So it's been in use for a couple thousand years, but if you look at how it's been used, the meaning has changed radically. So that might lead you to think, well, I can ask what atom means for Dalton, or for what it means for Bohr, but I can't ask what atom is independently of any paradigm. But there are also some pretty darn good reasons for thinking that relativism can't be true. Why? Well, as I mentioned, I think it was last time, in the Theaetetus, Plato said a lot of interesting things, and in his dialogue with Theaetetus, he gives an argument that philosophers for about 2,400 years have thought was a decisive refutation of relativism as a general view. Why? Really simply put, briefly put, Plato's argument is relativism itself only relatively true? So is relativism only relatively true? Relativism is the claim that truth always depends upon a perspective. Again, if you want to say, hey, Van Norden, doesn't truth sometimes depend on a perspective? Well, yeah, of course. The door is my left, your right. There's a bathroom upstairs or downstairs. I don't know what floor we're on. So if something's clear, that's not controversial. The interesting claim is if it turns out that everything's relative. That's where it gets interesting. And relativism is the claim that truth always depends upon a perspective. However, it looks like relativism is making an objective or absolute claim about all other theories. What do I mean? Relativism claims that truth always depends on perspective. In other words, whatever your perspective is, truth depends on a perspective. But I thought truth depended on a perspective. It does. And whatever your perspective is, even if it's different from mine, too bad, because you're wrong, because truth depends on a perspective. So it looks like the relativist is saying something that doesn't depend on a perspective. The relativist is saying, hey, all truth depends on a perspective. And that's true regardless of what your perspective is. If you disagree with me, you're wrong. Well, but I thought if I disagreed with you, I just had a different perspective. So if relativism is true, relativism is false. Because relativism is saying all truth depends on a perspective. But in saying that, it's saying something that doesn't depend on a perspective. But then, not all truths depend on a perspective. So it's false. That's really briefly Plato's argument. If you try to apply relativism to itself, it looks like it contradicts itself. And most people, since Plato, have said, well, that's a pretty good argument. Now, how does this apply to Kuhn? Now, again, if you read Postscript, Kuhn, you notice how he got kind of grumpy or irritable or angry about being called a relativist? He said, only philosophers have misunderstood my argument and taken me to be a relativist. As a professional philosopher, this happens all the time. People get really angry at philosophers. They killed Socrates, right? I mean, there's a reason they killed Socrates. Philosophers are really annoying. They keep asking questions people don't want us to ask, right? And so Kuhn's really annoyed that philosophers said, hey, it sounds like you're a relativist. And he says, I'm not a relativist. But there are things he says that sound relativistic. So it's worth asking, is he relativistic or not? Well, Kuhn claims that truth, rationality, and observation in science depend on, they're relative to your paradigm. That's what he says. However, Kuhn does not think that his own theory about science is true only relative to his own paradigm. Kuhn thinks he's got it right about science. Kuhn's saying, this is the way it really is. Other people are wrong about science. I, Thomas S. Kuhn, am right about science. And what am I right about? I'm right about the fact that truth, rationality, and observation all depend on your paradigm. Well, but then if we didn't agree with you, we'd be right according to our paradigm. No, you're wrong, because I've got the right theory about science. So Kuhn seems to think that his own theory about science is objectively true, but then not all truth is relative to a paradigm. So, and this is a problem that Kuhn's theory faces if he ends up being a relativist. And like I say, there are things he says that sound kind of relativistic. So, my sense so far, having talked to Chinese students, is, I could be wrong, on average, Chinese students are not as attracted to relativism. I know some of you are, but on average, you're not as attracted to relativism as American students. US students, 90% of them believe in relativism. And if you disagree with them, they'll be incredulous. They'll be like, what? If you say, well, I think there's some objective truth, like, what? Like, what do you even mean? It doesn't make any sense, right? And sometimes I give a lecture on relativism where I discuss Plato's argument, and students will come back the next year just to hear that lecture. You can see they're so excited. They're in the back of the room because they're like, you're the only professor who argues against relativism. I'm so happy. I've had physicists, defend relativism to me, and so, and I talked to a physicist and I said, well, but, how would you establish what is true in that case? And he said, truth, who believes in that? And I was like, well, I do, so could you answer my question, please? So my feel might be wrong, but my feeling is that on average, you're less relativistic than U.S. students, but maybe not. Maybe I'm just talking to the non-relativists. But just so you know, interesting fact, U.S. students, they're super relativistic. Super relative. They're all like, oh yeah, you gotta be a relativist. You're crazy if you're not a relativist. So that's what I wanted you to, some of the key points you should think about from Thomas Kuhn. Again, you don't have to agree, but at the very least, I think they present a lot of problems for Russell's view. Again, I don't know whether I mentioned this in class, I mentioned it in office hours. Russell was one of my heroes growing up. He was like, I was like, oh, I want to be like Russell because he was like brave in defending all these causes. And so he fought for women's right to vote when women couldn't vote in Great Britain. He opposed World War I, which was a big, stupid mistake. He campaigned to get rid of nuclear weapons because he said they might destroy the world. And so he did a lot of great things about Russell. And he's a very brilliant guy. But I think the theory he's got in the problems of philosophy, Kuhn raises some big problems for. Maybe you can save modernism, but Russell's version is going to have some problems, I think, because of the issues. So you decide what you think, but that's what I want you to learn from it. Now, I'm going to play with this for a second until I get it to work. I'm going to open another file. While I'm playing with this, now I wanted to reopen the USB with this. Oh wait, no, I see it. I think it's right. Is that what I want to do? No, that's not it. I don't want to take it out. I want to open it. That, okay. There you go. That's what I want to do. Alright, so while it's opening, I'm not going to do it quickly. Before you took my 5 minutes. Alright, so the next thing we're going to read, we're going to finish Kuhn. And we're finishing Kuhn. And now we're going to go on to Jean-Francois Lyotard and his book, The Postmodern Condition. I don't want to scare you. Lyotard is harder to read than Kuhn. But I understand he's harder to read, and I'm going to help you. First piece of help. When you read Lyotard, I've highlighted in yellow the most important sentences. If you only read and try to understand the sentence highlighted in yellow, that would still be a lot. So I'm going to, the readings, it's already on the QQ site, but I'll make sure that it's uploaded to the, copies uploaded to the discussion thing so you can find the next reading on Lyotard. But it is hard. He's hard in English too. It was originally written in French, translated into English. It is hard, but again, focus on the highlighted sentences, and I will help you a lot. And I understand it's hard to understand, so I won't expect. I mean, the thing about Russell is, Russell's really careful and exact. So you may not agree, but you can figure out what he's saying. Kuhn's are kind of hard, but he's still trying to be understood really carefully, so you can usually figure out Kuhn. Leotard, I think, is fascinating, but really hard to understand. But I'm going to help you a lot. So first, I'm going to give you a little bit of information, and this will help you with the writing assignment for next week. The introduction to the postmodern condition, which is part of what I'm going to have you read for next week, really summarizes all the major themes in the book. Gotta watch my time here, so I want to make sure I get to something. Let me skip ahead to something because I want to make sure I get to it so you're prepared to answer the question, and we'll go back. So Leotard says, and this is part of your writing assignment for the upcoming week, there are many different language games, a heterogeneity of elements. Heterogeneity means different kinds. They only give rise to institutions in patches, local determinism. That means to say, in a particular area where a language game is used, there's a clear determinate answer. What's a language game? The notion of a language game comes from Ludwig Wittgenstein's book, Philosophical Investigations, which is an even greater book than the postmodern condition, but even harder to read, so I didn't assign that. So what's a language game? Here's some examples of different kinds of language games. One language game is the descriptive language game. If I say the door is closed, well, in this case, that sentence is false, but we know it's a descriptive statement. It describes the world. It might describe it truly, or it might describe it falsely, but it describes the world. But that's not the only thing you do with language. And so part of the point Wittgenstein wanted to make in the Philosophical Investigations is this. Wittgenstein was originally a student of Russell, Bertrand Russell. And they had very similar views. And Russell originally thought that Wittgenstein was his greatest student. But Wittgenstein eventually decided that he and Russell were wrong. He said, Russell and I, we only focus on descriptive language as if that was the only kind of language there was. But Wittgenstein said, that's a mistake. The descriptive language game is just one game you can play. There are other games you can play. For example, there's the imperative game. Close the door. Imperatives are commands. Close the door is not either true or false, but it's a perfectly legitimate use of language. There can be appropriate and inappropriate uses of the imperative. For example, if I said to John Lauscher, if I said, hey, open the door, that's inappropriate. You know, he would do what he is doing, which is staring at me like, what? The door's already open. But that doesn't mean open the door is false. It means it's not appropriate given the fact the door is open. The statement is neither true nor false. Or the door ought to be closed. Prescriptive. It's not telling you to do anything directly. It's saying it really should be the case. And Wittgenstein is claiming, he's saying that Russell treats this, the door ought to be closed, as a case of a descriptive claim. And Wittgenstein says it's not. It's a different kind of use of language. Similarly, if I say, is the door closed? Not true, not false, not a command, not a prescription. The door! Exclamation. Not true, not false, not a command. So, and Wittgenstein calls these language games because he says, if you ask, what do games have in common? And he said, look at all the things we call games and see what they have in common. And he says, if you really look, you'll see they don't really have anything in common. Some games have some similarities to other games. Chinese chess and international chess, as it's called, Western chess, are probably both descended from an Indian form of chess. So they have some similarities. But what about poker? Or do people play Monopoly? That's a really popular game in the U.S. Monopoly or Scrabble. Or, I don't know what Chinese games, I only know Chinese chess, like Chinese game I know. But think of all the different games you could play, games you played as a kid, all the different games there could be. What do all of them have in common? You do them for fun. Some people play chess, they don't have a lot of fun. Or some people play poker and they do it for money. So it's not that all games are done for fun, it's that they have rules. Well, lots of things have rules that aren't games. Is that it? Do they have a rule? It can't be just that. And so Wittgenstein says there's nothing that all games have in common. They're just a bunch of different ones. And so likewise he says there are different language games and they don't all work the same way. Incidentally, Russell never forgave Wittgenstein for this. Russell was so disappointed in Wittgenstein, and he was just angry at Wittgenstein the rest of his life. Wittgenstein always spoke of Russell with reverence. Kind of Confucian in a certain way. It's just he's always like, Russell was his teacher, and he's like always said, if Wittgenstein's students tried to make fun of Russell, Wittgenstein would silence them and say, no, Russell's a great man and a great mind. I think he's wrong, but he's a great man and a great mind. And Russell was just like, I can't believe he does that. Ridiculous nonsense. But Wittgenstein says, no, Russell and I were wrong. There's more to language than just description of all these different games. So, one of the things Leotard does is he makes use of this notion of a language game. And Leotard says, science plays its own game. It is incapable of legitimating the other language games. The game of prescription, you ought to do such and such, for example, escapes it. But above all, it is incapable of legitimating itself as speculation, philosophical speculation, assumed it could. So what's he saying? He's saying different games have different rules. And if you ask, why is this the rule in poker? The answer is, because that's the rule in poker. Why is this the rule in chess? Because that's the rule in chess. Why do you say such and such when you're doing physics? Because that's how you do physics. What do you say such and such when you're doing, you're talking about what ought to be the case, or what is just, or what is fair? Because that's how you do that game. That's how you play that game. Interestingly, Wittgenstein was also a very religious person, but not a religious person in a conventional or ordinary way. And so Wittgenstein said, he was a Christian. One of the claims of Christianity is what? Jesus Christ was God embodied, and God died for our sins. And so Wittgenstein would say, he actually kind of says this in some of his writing. It's not in Philosophical Investigations, but it's in some of his other writings. He said, if you take a religious claim like this, if you treat it as a descriptive claim, well, it looks really stupid. But he says, that's not the language game it is. It's the Christian religious language game. It's not a scientific claim, not a descriptive claim. It's a religious claim, and it's a Christian religious claim. So, interesting idea. He says, religion has its own language games too. And he said, if you say, well, this doesn't make sense by the science language game, Leotard would say, and actually Wittgenstein would say, no, it doesn't, but so what? It's not playing the science language game. Or if you said, some philosophers think there's something very problematic about the nature of morality. Because they say, well, how does morality or ethics relate to science? But Wittgenstein would say, and Leotard would say, well, they're just different language games. You don't have to explain morality using science any more than you have to explain Chinese chess by appealing to poker. You don't use poker to justify Chinese chess, or Chinese chess to justify poker. They're different games. They each provide their rules. So that's how Leotard is using this notion of a language game. He wants to say that you have different language games. They each have their own rules. But because of that, science has its rules, and it can't justify them any more than any game can justify its own rules beyond saying these are the rules of the game. Now, the notion of a language game is not the same as the notion of a paradigm, but you can see they're kind of similar. If you've got a paradigm, you're playing a language game. Because there will be rules about what you can say and what you can't say. If you're playing the language game that Aristotelians were playing at the time of Copernicus, you can say something like, I know the sun moves because it says so in the Bible. That's a legitimate move in astronomy at the time of Copernicus. You can say, I know the sun moves. It says in the Bible the sun moves. Which it does. If you tried to make that move in modern astronomy, if you said, hey, I discovered something interesting, it turns out actually the sun has to move because it's in the Bible. What are you talking about? That's not a move. You can't do that. No, that's not a legitimate move to make in this game. Or if you said something like, oh, Confucianism has to be wrong. Confucianism has to be wrong because it's not consistent with Christianity. Wittgenstein would say, different language games. Can't judge one language game by another. So there are different scientific paradigms. Each one comes with a language game, different kinds of activities. Now, let me back up a little bit. That's really hard. Let me skip that for a second. Let me skip to something that I think will whet your appetite for reading Leotard. The expression whet your appetite the whet is written like that. Lots and lots and lots of really well-educated English speakers don't know that. So they think it's W-H-E, like pour water on it, wet. But if you want, there's the expression, if you know the expression, whet your appetite, it means like make you hungry for something. That's how it's written. So if you get that right, that's really impressive. Although actually some English speakers will correct it for you. They'll say, you got that wrong, there's no way it's there. Like, no, you're right, actually. Science can't legitimate itself. So Leotard's part of his basic view is there's all these different language games. They can't be used to justify each other because they're different games. Now, because there are all these different games, and we play different games, and we don't agree on which games to play, Leotard thinks this has political implications, some of which can be dangerous political implications. So Leotard says, the decision makers allocate our lives for the growth of power. And he doesn't even mean the power of the decision makers, he just means the power of society. In matters of social justice and of scientific truth alike, the legitimation of that power is based on its optimizing the system's performance efficiency. The application of this criterion to all of our games necessarily entails a certain level of terror, whether soft or hard. B, operation, that is commensurable or disappear. Now there's a lot going on there. The basic idea is this is how I understand it, we play all these different language games, right? And we don't agree about what language game to play, and we can't justify any language game over another because after all, they're different language games. What's the one thing we can agree on? The term that Leotard likes to use is performance or efficiency. Sometimes he says performativity. What he means is efficiency. Producing the most with the least. So more wealth, more consumer goods, more tax. Do you know that in the Vietnam War, let's see if I have this statistic right, the U.S. dropped more bombs, more explosives on North Vietnam than were used by all sides in World War II. I mentioned Robert McNamara before, and he was asked after the war, people said, did you guys think really carefully about whether it was necessary for the U.S. to fight the Vietnam War? You know what his answer was? He said, honestly, no. We just kind of assumed we needed to stop communism. Did you ask why you needed to stop communism? Honestly, no. So when you don't agree on what your goals are, the one thing you can realize is, let's be efficient. More wealth, more consumer goods, more bombs. Why? We know how to make more. More is better than less. Efficiency, efficiency, efficiency. At least we can agree on that. How much power are we producing in our generators? Can we produce more? That's an improvement. How many cars are we producing? Can we produce more? That's an improvement. So Leotard says, because of the profusion of language games, people only agree on the efficiency criteria. And he thinks this is one of the big problems with the West. That the West keeps doing is just emphasizing the performativity or efficiency criteria. And he says, as a result of it, in the name of achieving performativity or efficiency, it leads to terror. What is terror? Later in the book, Leotard says, by terror, I mean the efficiency gained by eliminating or threatening to eliminate a player from the language game one shares with him. He is silenced or consents, not because he has been refuted, but because his ability to participate has been threatened. There are many ways to prevent someone from playing. The decision maker's arrogance, which in principle has no equivalent in the sciences, consists in the exercise of terror. It says, adapt your aspirations to our ends or else. So Leotard's suggesting that part of the problem with the West is because the West has become obsessed with efficiency, since that's the only thing we can agree on. We know it's better to have war. How could it not be better to have war? Then, if anything is producing more, we say shut. Or you can't publish in this journal. Or don't say it. But that's a communist thing to say. Can't say it. Terror is used to silence anything that might question the performativity. And this has happened in U.S. history. So people who said things like, we really need to fight the Vietnam War, so you're a communist. Communist? You don't want to fight the Vietnam War? Well, maybe I am, but I don't have to be to think I shouldn't fight the war. You must be. Or now, it's more like the United States, and people say things like, I don't think it's a good idea to fight the war in Iraq. Oh, so you like terrorism. So you want the terrorists to win there. In other words, you silence somebody by making them afraid to speak out. the alternative to terror given all the different language games? That's one of the things we'll look at next year.